Hey there, Math 148, Section 14.3, Applications. What you've all been waiting for. You're probably thinking, why are we taking these second partial derivatives? I want to see an application. Lucky you. Question number 7. The joint cost in dollars for two products is given by this function. So the cost in x and y, 30 plus x squared plus 3y plus 2xy, where x is the quantity of x produced and y is the quantity of y produced. Are they clever or what? It would be a little more exciting if x was the amount of necklaces and y was the amount of bracelets, but whatever. So here's our cost function. And here are the questions. A. Find and interpret the marginal cost with respect to x if, it's supposed to be if, 8 units of x and 10 units of y are produced. And then part B, find and interpret the marginal cost, blah, 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 blah. Okay, let's start with part A. So, find and interpret the marginal cost with respect to x. Marginal cost with respect to x. This part jumps out at you. And you think, marginal cost, that's just a derivative. With respect to x, that's the derivative with respect to x. So when you start these problems, here's the question. You have this function, c of x, y, comma, is equal to 30 plus x squared plus 3 y plus 2xy, and part A is asking for the marginal cost with respect to x. So basically we want dc dx, and you're seeing, oh, I see why they made us do this dumb notation. I wouldn't call it dumb, I would call it clever. So this is with respect to x. With respect to x. R means with respect to x. So again, we've done this now a lot. I'm going to circle the x's because that's the variable. No x, there's an x, no x, here's an x. So in order to take this derivative, we're taking the derivative of this function in terms of x. Okay, the derivative of 30 is 0 plus derivative of x squared, 2x, plus 3y is a constant, so that is 0, plus 2, now y is a constant, and x, the derivative of x, is 1. So the marginal cost, I'll do it like this, the marginal cost in terms of x, right, is 2x plus 2y. Alright, but I'm not quite done yet because the question said if 8 units of x and 10 units of y are produced. So now you look at this second part. So remember this first part here in yellow was find, you could call it marginal cost, or maybe think of it like this, cx, the derivative in terms of x, or dc dx, that's not math type, but anyway, the first part here is finding the derivative. This second part, if 8 units are produced, this means plug in, substitute, x equals 8 and y equals 10 into your derivative. So let's do that. So here's our derivative, and now we're going to let, it said x was 10 units, no, 8 units of x, and y is 10 units of y. So we're going to plug this in to find the marginal cost with respect to x at that point when 8 units of x, is 2 times 8, plus 10 units of y, 2 times 10. Uh-oh, that's 16 plus 20. I can do that one in my head. That's $36. So the answer, find the marginal cost with respect to x. All of that, it's a long sentence here. Find, we haven't interpreted yet, the marginal cost with respect to x if 8 units of x and 10 units of y are produced. The answer is $36. That's not part B, by the way. But we have not yet interpreted it. So let's interpret. And this is the interpretation sentence. Actually, I'm going to pause it and write out the interpretation sentence so you can actually read it. Okay, here's the interpretation. If y remains at 10, the expected change for a 9th unit of x, or as x goes from 8 to 9, is $36. So why are we saying y remains at 10? Because we're looking at the marginal cost of x. So x is the thing that's changing. So if y remains at 10, because remember we were looking at 10 units of y, If y remains at 10, the expected change for the 9th unit, right, as x goes from 8 to 9, is $36. So this is a variation on the marginal cost with respect, on the marginal cost interpretation with respect respect to x. Okay, so let's look at part B. Find and interpret, the interpretation, the marginal cost with respect to y, so we switched it up, if 8 units of product x and 10 units of product y are produced. Do you see how they just switched it around? They switched it on us, so it's very similar to part A. They just slightly changed the numbers. Did I get those numbers right? I'm checking. 8 and 10, and then they had 8 and 10. So they just totally flipped x and y. But we can do it. So the difference now is find and interpret the marginal cost with respect to y. Are you seeing how this is going to be different? Are you thinking marginal cost with respect to y? This looks like this. Here's our cost function. Cxy is equal to 30. I'm just rewriting the function to have it down. 3y plus 2xy. So for part B, we want the marginal cost. So you can think of it like this in terms of y, or you could think of that as dc dy, the derivative of c in terms of y. So in order to find this, what's our variable? Y. So let's circle all the y's that we're going to use. There's no y, there's a y, there's a y. So here's our derivative. The derivative of a constant is 0 plus x squared is constant, 0. Are you liking this part already? The derivative of 3 times y is, I'm writing plus, but there's nothing else there. 3 times 1, right, derivative of 1, plus 2x is a constant, and derivative of y is 1. So we have 3 plus 2x. So it says find the marginal cost with respect to y. Looks like this. That was find it. Oops, but we're not done yet because we have to plug in the numbers at the point, make sure I'm getting this right, part B, if 8 units of x and 10 units of y, so they kept the units the same. Before we were also using 8 units of x and 10 units of y, but now we're changing with what we are taking it with respect to, the marginal cost. So now we're going to plug in the marginal cost of y at x equals 8, y equals 10. Well, let's see, we have 3 plus 2 times x equals 8. There's no y, so we actually don't need that piece. That's fine. So that's 16 plus 3, 19. Gotta love these little numbers. So the marginal cost with respect to y, I'll go back to the problem. The marginal cost with respect to y if 8 units of x and 10 units of y are produced equals $19. It's such a short little answer for a calculus problem, isn't it? $19. Interpretation. So it said find and interpret. So here's the interpretation. Part B. If x remains at 8, the expected change for an 11th unit of y, or as y goes from 10 to 11, is $19. And again, because we're doing an expected change of y, we say if x remains at 8, here, I'm going to bump this down a bit. There. The interpretation, if x remains at 8, the expected change for an 11th unit of y, or as y goes from 10 to 11, is 19. This one goes up to 11. So you should be able to work problems like this where you find, I'll go back up to the problem. You have some cost function and it says find and interpret the marginal cost with respect to either x or y if, and then it gives you some units to plug in. So again, your strategy for these are take the marginal cost with the right derivative and then plug in the numbers at the end. Okay, good luck.